Good morning to all. In this session, we are going to discuss Fourier integral, exponential integral. In the previous session, we discussed Fourier integral formula. Now, in this session, we are going to discuss Fourier exponential integral, and after that, we are discussing Fourier integral theorem. These two are the important concepts now we are going to discuss. Let us start. Now, just look at here, we are going to discuss Fourier exponential integral. Fourier exponential integral and Fourier integral theorem as well. Fourier integral theorem as well. So, in this session, we are going to discuss Fourier exponential integral and Fourier integral theorem. Okay, these two are being asked for 2 marks. Actually, these two are 2 separate topics. One is Fourier exponential integral. Second topic is Fourier integral theorem. Got it? Now, just look at first concept. The concept is Fourier exponential integral. Students have to understand the word integral. Understanding, as long as we are using the word integral, 2 integrals will be representing in the formula. Now just look at actually the Fourier integral of any signal, that is equal to 1 by 2 pi minus infinity to infinity minus infinity to infinity the f of x into cos u of t minus x into dt du into dt du. Got it? Now, its exponential format, its exponential form is equal to, so Fourier exponential integral of a function that is equal to 1 by 2 pi minus infinity to infinity e power minus, this is imaginary number j u x du into minus infinity to infinity the function f of x into e power plus j u t into dt. Look at, very easy to write this format. 1 by 2 pi, 1 by 2 pi. Minus infinity to infinity, minus infinity to infinity. Just look at cos u of t minus x. Actually, this is cosine term. Now, again come back, e power I theta. It can be expressed as cos theta plus I sin theta. That means what? Indirectly, cos term is existing in the e power I format, I theta format. In maths we use I. In electronics we use j only. Now just look at here, cos u of t minus x. Multiply with this one, cos, this will become cos ut minus ux. Now just for you take this one, this can be written as e power minus j ux. Minus j ux. With respect to variable, which one? Du. The second one is go for this one, ut. So once it is negative, no need to form negative. Next positive, j u t with respect to t only. Now just look at 2 integrals, no change in this basic structure. Constant 1 by 2 pi, 1 by 2 pi, no change this one. But here it is splitting into exponential format only. The name Fourier exponential means what? Instead of writing cos term, express cos term in terms of exponential format. That is called exponential form of the Fourier integral. Now here two integrals like this. One is e power minus j u x with respect to variable u. Second one is f of x into cos plus j ut. Here with respect to t only. Already with respect to u is done integral. So the remaining variable is t. This is Fourier exponential integral. So before writing Fourier exponential integral, you are supposed to know the Fourier actual integral formula. From this formula only we will be able to write Fourier exponential integral. This is asked in most of the cases. For 2 marks they are asking. Write the Fourier integral formula. They are asking for 2 marks. They are asking for 2 marks. Now what is Fourier integral theorem? Now the second concept is Fourier integral theorem. This is Fourier integral theorem. What is Fourier integral theorem? Now just look at, before starting this third unit, we discussed Dirichlet's condition. Dirichlet's condition, well, what is the main purpose of Dirichlet's condition? Dirichlet's condition always says that the given Fourier series converges to a single value. Converges, the word is converges to a single value. Similarly, the Fourier integral theorem is also says the convergence of Fourier integral. What is Fourier integral theorem? This theorem says that the convergence of Fourier integral, that is important, students have to know it. Fourier integral theorem implies, it says, the Fourier integral says that, this says the convergence. It says the convergence of Fourier integral. The convergence of Fourier integral is called Fourier integral theorem. Now just look at. Let a signal or function f of x be expressed in Fourier integral. Look at, in Fourier integral, or you can make it Fourier series also, no problem. You can make it Fourier series, in Fourier series. Now it satisfies, now this f of x satisfies Dirichlet's condition. What does it satisfies? Dirichlet's condition. It satisfies Dirichlet's condition. Also assume that, let assume that minus infinity to infinity f of x dx is absolutely convergent. Convergent. Got it? So no need to have any confusion. Generally, a mathematical function is regarded as a signal in electronics. By generally we write f of x like that. Now students can also use t also. In case of this, you can use also t also. Both are same. If you make x, keep all x dx. If you use t, you can use t dt like that only. Both are same. Got it? Now again just look at a signal f of t be expressed in Fourier series. But we are talking of regarding what? Fourier integral theorem, not formula. Formula is different, theorem is different. Formula means double integral, big formula. Theorem always says about the convergence of the Fourier integral. Convergence means convergence to a single value. Now just look at, let f of t be a signal expressed in Fourier series. It also satisfies the condition of Dirichlet's condition. Let us assume that f of t dt integral between minus infinity to infinity is absolutely convergent. We have to assume that. If these three conditions are satisfied, then the Fourier integral of the given function or signal converges to f of t, converges to signal converges to half into f of t minus 0 plus f of t plus 0. Now just look at, that is called Fourier integral theorem. Fourier integral theorem. Integral formula is different, theorem is different. Theorem always says about the convergence of the theorem. That means the theorem converges to a single value. What is that value? This is the single value. Here t minus 0, this is called left hand limit. This is called right hand limit. Right? Just like how we discussed the Dirichlet's condition in the Fourier series before starting this third unit, the same concept here we are using. So before discussing Fourier integral, again we have to start with Fourier series. That's why just look at f of t be a signal that can be expressed in Fourier series. Let the signal satisfies the Dirichlet's condition. Let the signal between minus infinity to infinity dt, that is absolutely convergent. If these two conditions are satisfied, then a given Fourier integral of a signal f of t converges to a single value. What is that value? Half of f of t minus 0 plus f of t plus 0. This is the Fourier integral theorem. Got it? Now, here just look at, now I will make you the main concept in a single capsule. Now just look at Fourier integral of any function or signal can be written as 1 by 2 pi. This is minus infinity to infinity, minus infinity to infinity, the given signal f of x into cos u of t minus x dt du. dt du. Understanding? This is Fourier integral. Now, Fourier sine integral of any given signal or function, this can be written as 2 by pi 0 to infinity f of x into sine ut into sine ux into dt du. Look at, no need to have any confusion. That's why again I am writing all the formula for your understanding purpose. Now, Fourier cosine integral of the function or signal f of x can be written as 2 by pi integral 0 to infinity of f of x into cos ut into cos ux into dt du. So just look at, students have to remember what is Fourier integral, what is Fourier sine integral, what is Fourier cosine integral. Look at the formula and understanding the terminology and terms, very easy to understand. Now here we are writing what is Fourier exponential integral of a given signal f of x or f of t, that is 1 by 2 pi integral minus infinity to infinity. Look at this one, cos u t minus x, take the first negative one, that is equal to e power minus exponential j of ux with respect to du. Next one, minus infinity to infinity of the function f of x into the remaining term, that is e power plus ut dt. This is Fourier exponential integral. Now just look at Fourier integral formula. That means it contains two integrals. Next one, Fourier integral theorem. This theorem always says about convergence. It says about only convergence of a given signal or function f of t. It converges to the value of half f of t minus 0 plus f of t plus 0 only. Understanding? Now this is the overall essence of this given session or capsule. So this is Fourier integral, Fourier sine integral, Fourier cosine integral, Fourier exponential integral, and Fourier integral theorem. Integral is different, theorem is different. Integral says formula, theorem says convergence. Thank you.